Is Earth really the only home for life in the universe? Earth is the only known planet that harbors life. In the vastness of the cosmos, it's nothing more than a tiny speck of dust. Yet humanity has never stopped searching for intelligent life beyond our world. Earth is one of the 8 planets in the solar system, and our solar system sits on a spiral arm of the Milky Way called the Orion Arm. So far, all our explorations have found no evidence of life elsewhere in our solar system. That means, for now, humanity is alone here. But could life exist elsewhere in the Milky Way? Could we be just one of many civilizations? According to the Hubble telescope, the number of stars in the observable universe is roughly 10,000 times the number of grains of sand on Earth. And that's just the part we can see. Beyond that, there may be infinite unknowns. Even if we only focus on the Milky Way, it's estimated to contain around 200 billion star systems. If each star system had 8 planets, like ours, there would be roughly 1.6 trillion planets in our galaxy alone. Earth is just one of them. Even if the odds of life forming are low, with numbers that big, the chances of life elsewhere are still high. Since the 20th century, scientists have been trying to estimate how many civilizations exist in the universe. One of them, American astronomer Frank Drake, proposed a famous equation to estimate this number, the Drake equation. It includes 7 variables. Depending on how you plug in the numbers, the results suggest there could be anywhere from 10,000 to 1 million civilizations in the Milky Way. So here's the big question. If intelligent life is out there, why haven't we found it yet? The answer is simple. Even at the speed of light, it would take 100,000 years to cross the Milky Way. And our current technology is nowhere near that fast. It's not that we don't want to find alien life. It's that we're not technologically advanced enough yet. If you've read the sci-fi novel The Three-Body Problem, you might remember this idea. The universe is like a dark forest. Each civilization hides its location, fearing being destroyed. No one dares to reveal themselves, let alone invade others. Or maybe Earth is simply too primitive. Higher civilizations might not even care to contact us. According to the Kardashev scale, which ranks civilizations by their energy use, Earth hasn't even reached Type 1 yet. But with each scientific breakthrough, we move one step closer to the stars. One day, we may discover life beyond Earth, and maybe, just maybe, make contact. Germany YouTube. Ist die Erde wirklich der einzige Ort MIT Leben im Universum? Die Erde ist der einzige bekannte Planet, auf dem Leben existiert. Im unendlichen Universum ist sie, kaum mehr als ein winziges Staubkorn. Doch die Menschheit hat nie aufgehört, nach außerirdischem Leben zu suchen. Unser Erde gehört zu den 8 Planeten im Sonnensystem. Das wiederum in einem Spiralarm der Milchstraße, dem Orionarm, liegt. Trotz aller bisherigen Forschungen fanden wir im Sonnensystem kein weiteren Anzieken von Leben. Das bedeutet, der Zeit sind wir alien. Aber gibt es vielleicht Leben irgendwo anders in der Milchstraße? Sind wir wirklich die einzige Zivilisation? Laut Beobachtungen des Hubble-Teleskops gibt es mehr Sterne im beobachtbaren Universum. Als Sandkorner auf der Erde. Und zwar das sind falsch. Und das ist nur das Universum, das wir sehen können. Was sich dahinter verbirgt, ist völlig unbekannt. Schon in der Milchstraße alien schätzt man rund 200 Milliarden Sternsystem. Wenn jed so wie unser Sonnensystem 8 Planeten hat, gäbe es etwa 6 Billionen Planeten. Und die Erde wär nur einer davon. Selbst wenn die Wahrscheinlichkeit für Leben gering ist. Wären bei Dyson sollen Andir bewant Welten fast sicher. Seitdem 20. Jahrhundert versuchen Wissenschaftler zu schätzen. Wie viel Zivilisationen es im Allgemeinen kann. Der US-Astronom Frank Drake entwickelt dazu die berühmte Drake-Gleichung. Die MIT7 Variablen arbeitet. Je nach Berechnung kommen wir auf 10.000 bis 1 Million Zivilisationen, alien in der Milchstraße. Doch warum haben wir bisher keine einzige gefunden? Ganz einfach. Selbst MIT Lichtgeschwindigkeit braucht man 100.000 Jahre, die Milchstraße zu durchqueren. Und die unsere Technologie ist weit davon entfernt. Es liegt nicht in mangelndem Willen, sondern in unseren begrenzten Möglichkeiten. Den Roman die drei Sonnen, Three-Body Problem, gelassen hat, kennt vielleicht dies Metaphor. Das Universum ist ein dunkler Wald. Jede Zivilisation Versteckt sich, Aus Angst entdeckt und Ausgelöscht zu werden. Niemand wagt es, sich zu sagen. Oder vielleicht ist unsere Zivilisation einfach zu primitiv. Hoher entwickelt Wesen sehen keinen Grund, mit uns in Kontakt zu treten. Laut der sogenannten Cartesco-Skala, die Zivilisationen nach ihrer Energienutzung einteilt. Hat die Menschheit noch nicht einmal Stoff unterrichtet. Doch mit jedem wissenschaftlichen Fortschritt rücken wir den Sternen nachher. Vielleicht entdecken wir eines Tages tatsächlich außerirdisches Leben. Und treten mit ihm in Kontakt. Could humanity ever glimpse the existence of a Type II civilization in the universe? Back in September 2015, the Kepler Space Telescope detected a strange star in the constellation Cygnus, 1,480 light-years from Earth. Its name, Tabby's star. What caught astronomers' attention was its highly irregular changes in brightness. Normally, when a planet passes between a star and Kepler's line of sight, it blocks part of the star's light. For example, when Jupiter crosses the face of the sun's brightness drops by about 1%. If an alien astronomer were watching our solar system, they could detect this drop, calculate Jupiter's size, and determine its distance from other planets. In the universe, many star systems show such regular patterns of brightness changes. But Tabby's star was different. Its light curve was asymmetric, and the timing of the dips was erratic. A Yale University research team later made a shocking discovery. Since Kepler began its mission, it had recorded irregular dips in Tabby's star's brightness. In March 2011, the star's brightness dropped 15% in just 1 week, then returned to normal a few days later. In February 2013, something even stranger happened. In less than 100 days, its brightness plunged by 20%. For perspective, even the massive Jupiter can only block about 1% of the sun's light. A 20% dip suggests the object doing the blocking would be at least 20 times larger than Jupiter. But according to modern science, such a planet cannot exist. It would collapse under its own gravity, ignite its core, and become a star. Over the years, Tabby's star showed periodic changes every 2 years, but more recently its light variations have become even stranger, as if many irregularly shaped objects were orbiting it. One leading theory points to something extraordinary. The Dyson sphere, first proposed by Freeman Dyson in 1960, a hypothetical megastructure that could encircle a star to capture its energy. According to the Kardashev scale, any civilization capable of building one would be classified as a Type II civilization. If Tabby's star's 20% dimming represents 20% completion of a Dyson sphere, could the increasingly frequent changes in its light spectrum mean the builders have found a faster way to construct it? Even more intriguingly, other stars near Tabby's star have also shown signs of dimming, suggesting they might be building multiple Dyson spheres. On May 17, 2021, China's High-Altitude Cosmic Ray Observatory in Daocheng, Sichuan, detected a gamma-ray signal from the direction of Cygnus, light that had traveled for 10,000 years. All these clues hint at one possibility. Somewhere in the depths of Cygnus, there may be a hidden alien civilization. And the strange phenomena we see, could they be the work of a legendary Type II civilization? If you could travel at 1 light-year per second, where would you end up? Let's start with a basic concept, the speed of light. The speed of light is the fastest speed known in the universe, about 300,000 kilometers per second. Enough to circle the Earth 7 times in a single second. Sounds fast, right? But in the vastness of the cosmos, it's painfully slow. Even light takes at least a year to cross our solar system. That's why we use another unit, the light year. The distance light travels in a vacuum in 1 year, about 9 trillion kilometers. Now, fasten your seatbelt. The captain is about to accelerate our ship to 1 light year per second. 1 second, you've already left the solar system. 4 seconds, you've reached Proxima Centauri, the nearest star to Earth, part of a triple star system, and the fictional home of the Trisolar Ants. 8 seconds, you arrive at Sirius, the brightest star in the night sky. After 10 minutes, you reach Kepler, 22b, one of humanity's most promising candidates for future colonization. With current technology, it would take more than 10 million years to get here. After 2 hours, you witness one of the most breathtaking sights in the universe, the pillars of creation, made famous by the Hubble Space Telescope's iconic images. After 5 hours, you arrive at the largest known star, Stephenson 2-18. Its radius is 2,158 times that of the Sun, capable of holding 10 billion suns or 130 quadrillion Earths. After 1 day, you leave the Milky Way, seeing its full shape for the first time. After 29 days, you reach our neighboring galaxy, Andromeda. It's even larger than the Milky Way and is set to collide with us in about 4 billion years. After 115 days, you're at the edge of the Local Group, a collection of over 50 galaxies, including the Milky Way and Andromeda. After 3 years, you realize the Local Group is just a tiny part of the Virgo supercluster. After 16 years, you pass through the Laniakea supercluster, where the Milky Way is nothing more than a speck of dust on a cosmic feather. After 100+ years, you reach the largest known black hole, TON 618. Its mass is 66 billion suns, a true cosmic monster. After 1,000+ years, you finally arrive at the edge of the observable universe, about 46.5 billion light-years away. But remember, this isn't the end of the universe. It's simply the limit of what humans can currently observe. Beyond this boundary, scientists believe there may still be endless cosmic space. Even at 1 light-year per second, we still cannot touch the true edge of the universe. And so we must ask, in this boundless cosmos, how small are we really? If you're fascinated by the mysteries of the universe, don't forget to like and subscribe. See you in the next video.